Or we can just do one example
Oh
and then I'll.
Okay, let's do what we gotta do.
Oh
Ow.
my goodness.
Jeez, that hurts.
Yeah, how come Secret Santa, Yoshida, none of the 10th graders signed up? I wonder. You guys probably never even read the email. Oh yeah, besides Josh.
Just synthetic division, please.
No, there's no synthetic division.
Okay, I
We
don't
did
know.
this on the board, we
Right.
synthetic division. Huh?
Okay, we're gonna do number, okay, 16 or, stop!
Maybe I can.
16 or 17, try.
Uh,
Yoshida, sit down.
you pick Mr. Gordon.
No, you pick.
I don't know. Which one is easier?
They're both easy.
Oh, okay. 7.
Probably 17 is a bit hard. Okay, show that 3 will divide, Yoshida, sit down. 4 to the n minus 1 for all positive integers n. Okay, so how do you, what's the first case you gotta show?
Base.
So this is p of 1, right? So, oh no, this is p of n. So we have to show p of 1 is true. Well, does 3 divide 4 to the 1 minus 1?
Yes. Check.
Yes. Now we have to show that if this statement is true for any integer, it is true for the next integer.
Mr. Park, if you look, Trevor Arshiro said he will visit you at 1 o'clock.
Yay.
See you 1 o'clock.
We have class at 1 o'clock.
Oh no, I have class. I can't teach.
Okay, so
Be here at lunch window.
what is p of k?
3 divides 4 to the
Three.
k minus 1.
4 to the k minus 1. And what is p of k plus 1? 3 divides 4 to the k plus 1.
Working backwards
Minus
is
1.
better.
Okay, so what is the definition of 3 is a factor of this?
3k.
No.
4 to
Oh
the
yeah, I guess 4 to the k minus 1 is equal to 3 times some integer, what letter do you want to use?
n.
3m for, well, we already have in there, yeah? Where m is an element of the integers.
Yes.
Okay, now what? See now, what, if you have to show this, what would be the step right before this one?
Factor the 4.
4 to the k plus 1
Equals.
minus 1
Minus 1 equals 3.
is equal to 3 times some integer, right? Right?
Yes.
That's why you gotta know the definitions, yeah.
Can you just not do that and then go from 4k plus 1 minus 1 and then factor the 4 out?
Factor the
And then
Yeah,
say
well,
that
that's going backwards, but when you write it, nobody knows which way you're going, right?
Yeah, but you don't need to like do the thing with n.
No, but then for instance, people who have a hard time, then
Oh.
they need to see like what is the step before, right? Okay, so how can I get from here to here?
4 times.
Like, this is 4 to the k plus 1, huh? What could I do to this equation to get 4 to the k plus 1?
It's 4.
You multiply both sides by 4. So in this step, multiply both sides by 4, and so you get 4 to the k plus 1 minus 4 is equal to 3m times 4. Why don't we just say 12m? Hello. Okay.
Add 3 to both sides.
Add 3 to both sides. So 4 to the k plus 1 minus 1 is equal to 12m plus 3. And is that equal to 3 times some integer? Yeah, 4m plus 1. Because if m is an integer, then 4m plus 1 is also an integer. And what is that called again? Yeah, so the set of integers is closed under addition and multiplication, right? And there you go, there's your proof. So if you need to work backwards sometimes, work backwards. That's no secret, everybody does that. Well, some people don't. Okay, today we're just gonna learn the Euclidean algorithm. Both of these will show up on the test when we come back.
What?
It's so cool.
Oh, what?
I'm sorry, the test is gonna be when we come back. That's just the way it is.
What? They just test. The day we
Do I
come
have to
back.
say it 3 times?
We
Said
did.
it was
Well,
a-
Nasu thought the test was today, because that's what I said last week, right?
Wait,
But it's not.
is it right when we come back?
No, not right when we come back. Because when we come back to school, isn't the first day basic?
No, E day, F day, basic.
Oh, it's
1, 2, 3, 4.
extended, basic.
5, 6,
So basic
7,
then
8.
will be the test. It'll be a very short test.
Because we only have like 30.
In fact, why don't we'll just do a practice test then the first day back.
Okay.
Okay, look, oh gosh, I gotta scroll.
Is it not the screen?
No, this is just a TV. That's why Lamachani last year brought in a
Oh, that's a
mouse one
mouse
time.
thing, yeah, just plug into it.
Okay, look at this Euclidean algorithm. If for positive integers a, b, and r, a is equal to bk plus r for some integer k, then the greatest common divisor of a and b is equal to the greatest common divisor of b and r.
Is it denominator? Divisor.
Divisor. Great. What did I say? Did I say denominator?
You said
No.
divisor.
Yeah, I'm confused.
Use the denominator.
Okay, so let's think of two really big numbers where we have to find the greatest common divisor.
1009.
No. Something that.
That fact.
How about 1728 and
2018, Mr. Factor. Nice. Pretty sure.
2009?
2018 factors into 2, 1009, 1009 factors into like 11 something.
Why is it ABR and not ABC?
Or
I don't know. That's just where you. It doesn't matter what letters you use, right? Okay, think of another number that's like, let's say an even one.
Oh, okay. 308.
420.
308.
What?
420, sure.
Sure.
What did you say?
420.
400.
Okay, I was thinking something like 432. Okay, why don't I just make up the numbers? Okay, find the greatest common divisor of both of these numbers. Okay, so we're gonna use the Euclidean algorithm.
Yay.
So I'm trying to remember how I did this before. So you gotta take the bigger one, right?
On the left.
1728
Equal.
is equal to 432
Times something.
times some integer plus something, right?
Yeah.
Okay, so let's fill in the numbers. You guys gotta do some arithmetic here.
4. No. Yes.
4,
Wait, 4.
exactly.
Exactly 4. That's a hard.
Okay,
That's a hard.
That's a bad number.
That's a
then.
bad number.
Strip
It's
apart.
done.
Okay, that's a bad number then. That's okay.
4.
Let's not do. How about 576 then?
Sure.
Sure.
Also 3.
Wait, is it 3?
No, it's good.
3.
Wait, is it 3?
Might be.
There's no way. Is it 3?
No way.
Is it 3?
No.
No.
576
No.
times 3.
It's not.
8 carry
Yeah.
1 carry 2.
No.
No, it is.
It
Okay, that,
This is 4.
hey, I'm sorry. I'm trying to think of numbers here.
690.
No, but that's junk. You gotta think of like something that would be hard to figure out. 30. What did we do? 432, now 576.
576. You picked all the nice ones.
854.
How about 300 something then?
302.
What number in the 300s has a lot of factors?
302.
302 has a lot of factors?
324.
Okay, 324
Oh,
sounds
sure.
right.
I don't know.
Sounds good.
324 sounds right. Okay, 324 goes into 1728 how many times?
5.
Exactly.
No,
No.
No, it's
So-
not. It's not. It's not.
Okay, so 1728
16.
divided by 324, you said 5 times?
Sure.
So 0, carry 2, carry 1. How much remainder got? So it goes 5 times with remainder
108.
yes, 108. Okay, now we're getting somewhere.
Yeah. And
Okay.
then move it.
Okay, now what?
Yeah.
Just move the 324 and the 108.
24 to the-
So the 324 is equal to 108 times something plus something. 108 equals 3 times.
Mr. Fart.
Congratulations, we're done. We're done. Do you want some numbers?
So what's the answer? What's the answer?
I don't
The
understand the
answer
question.
is,
The answer is 108.
108, yeah.
Yeah.
That was.
Wait, do you want some numbers?
No, that's okay.
I don't understand.
And then you just keep on doing this until you get the 0 remainder here.
Wait, the
Greatest
greatest common
common divisor.
factor is 108.
Why, you have that on your calculator?
Don't know.
Trent, stop playing around. Do something.
Is it one
On your
calculator?
what do you call this thing?
iPad.
On your iPad, find the greatest common divisor for this. Wolfram Alpha, or just punch it in. Can't you speak to your thing? What is it?
Hey
you call this?
Siri.
Yeah.
There you go. Hey Siri, what is the greatest common
Mine is
divisor?
Mine is in Chinese.
Wait,
so
is
I don't think I
Why, you can speak Chinese? You can, right?
What is it in
Don't let song beat you, Trent.
I don't know.
Just do GCD.
Just GCD, just take this in.
Siri.
Is it greatest common factor?
No,
GCD.
that's the same thing.
Hey
108. 108.
See, there you go. Okay, don't worry, the one I give you in the test not gonna be this easy.
Same thing though.
Okay, now the Chinese remainder theorem.
Easy.
Easy. No, but there's some things you gotta go through though, you know.
Yeah.
It's not as easy as you think. Now there was a famous problem in mathematics. What is that crinkling I hear?
Trying to solve the leech us out.
Yeah, I got banned yesterday because I left
You got banned?
for like 20 minutes.
No crinkling, throw that away right now. Give it to me.
I can throw it.
No, give it to me.
No.
Okay, so what is the small? Okay, what was that famous problem? Yoshida must have heard this. What about who? Like, I don't know how many sheep I have, but I know that when I divide it by 2, there's 1 left over.
Yeah.
Divided by 3.
Oh yeah, this.
But when I divide it
3.
by 3, there's 2 left over. When I divide it by 5, there's 3 left over. And when I divide it by 7, there's, you want to do 4?
69.
4.
Or you wanna
just
change?
Chinese remainder theorem
7.
twice.
Okay, 4 left over.
Yeah.
So what's the smallest number of sheep that I can have?
Guess and check.
Remainder theorem twice.
You think you could guess and check this?
Yeah.
Okay, but we're gonna do it on an easy example. When we do it on, so when you do the Chinese remainder theorem, look at it. It says, let M1, M2, M sub n be pairwise relatively prime. So then that's these numbers right here.
What does
They have to be relatively prime.
That's pairwise.
Pairwise, that means if you take 2 of them, the greatest common factor would be 1. So what's the greatest common factor of these 2?
1.
What about those 2? What about those 2?
1.
What about those 2?
1.
What about those 2?
Oh, okay.
What about those two? See, they're pairwise relatively prime. So in other words, you can't have 2, 3, 5, 8 because 2 and 8 are not relatively prime, that's why. So then you wouldn't be able to use the Chinese remainder theorem. Okay? So look at all of these letters you gotta do here. Let A1, A2, an be any integers. Now, given this system, so what we have to do is we have to translate this into the system right there. So x is the number that we're looking for. So x has to be congruent to what?
2 mod 1.
Is it 2 mod 1 or 1 mod 2?
1, 1, 2.
It's 1 mod 2.
Oh,
How come?
Because
Because
there's
if
one
you
remainder
divide
and
by
Because
remainder.
x and 1 have the same remainder when you divide it by 2.
Mhm.
Right? Because you said when you divide it by 2, you get 1 left over, right?
Yes.
Okay, so this number we're looking for also has to be congruent to, looking at the second one here,
Mod
2 mod 3. X, and then this number we're looking for has to be congruent to 3 mod 5. And finally, the number we're looking for has to be congruent to 4 mod 7. So what numbers satisfy this property here? So, if you're looking at this thing, this is A1, A2, A3, A4, right? This is M1, M2, M3, M4. Okay, now it says, let capital M be equal to M1 times M2 times M3, for this particular case all the way up to M4, which is?
7.
What?
What?
2 times 3 times 5 times 7.
Oh,
Okay, why don't we just leave it at that? And for each I, m sub I equals m over mi. Okay, so capital M sub I is equal to capital M, which is this, divided by small mi. So therefore, what is capital M sub 1? See, you gotta be able to follow this. This is M. Okay, so what happens when I plug in 1 for I? You're gonna get M, which is this. Here, I'll just do it for the first one. 2 times 3 times 5 times 7, divided by M sub 1, which is 2. So what does that come out to? Really? 3 times 5 times 7.
No, I don't know.
Right? You see what's happening?
Mhm.
What is capital M sub 2 equal to? It's capital M, which is 2, why do I even write in parentheses? Whatever. Divided by small m sub 2, which is 3, and then you're gonna get 2 times 5 times 7.
70.
Yeah, I'm sure you can compute these numbers.
Yeah. it's
M,
pretty-
capital M sub 3 is 2 times 3 times 5 times, after a while, you don't even have to do this, you kind of know what's going on already, right? Divided by, what is small m sub 3?
7.
No,
5.
5, which is
42.
2. Yoshida, you're acting like this is 4th grade math. Oh my goodness. I think next year, will they be more mature next year?
I mean, yeah.
Lie.
Harry and Salvin.
Okay. What about those other people? There's a whole bunch of them, right?
Lie.
Gabriel Kong.
I read it.
Walk. Okay, whatever.
Kojima.
Kojima.
I don't know these people.
2 times
30.
times 5. Okay, so Tran can do arithmetic. Okay, so we got our capital M's over there. Now, for each I, find x sub I such that mi xi is congruent to 1 mod m1. Okay, so let's take the case when I is 1. Okay? So if I is 1, that means capital M1 x1 has to be congruent to 1 mod, what? Mod m1. Okay, now what is capital M1? No, right there.
357.
Let's plug it in. What's capital M1?
105.
Okay, 1. Where are you now, Trent?
Yes.
And what is small m1? That would be this number on the bottom right there, right? That's so mod 2. So what you have to do, you have to find x sub I. So what is x sub 1?
1, 1, 2.
Yeah, so you just have to find some. You don't have to find like all of them. Just find one.
1.
Everybody see 1 works?
Yeah.
Because if you plug in 1 there, that means 105 minus 1 is divisible by 2.
Yes.
Okay. Okay, so now what happens when you plug in 2 for I? What is capital M2? 2 times 5 times 7.
Oh, they're 70.
So 70 x sub 2 gotta be congruent to 1 modulo 3.
1.
Okay, what number could x sub 2 be? What integer?
Oh wait.
Can it be 1?
Yeah.
Yeah, 1 works as well, right?
Mm.
Because if you plug in 1, that's 70. 70 minus 1 is divisible by 3.
69 divided by 3.
So is that a yes then?
Yeah.
Okay. Okay, what about when I plug in 3? So M's 3 is 2 times 3 times 7, which is,
Yes. 42.
that's not a yes or no question. It's congruent to 1 mod 5. So what could x sub 3 be?
3.
Can it be 1?
3.
No. 2?
You're right, Trump.
No. 3. Oh, very good. 3. Tran, you're a potential mathematician. Okay, what about M4 now? What is M4? 2 times 3 times 5.
30.
30 x sub 4 is congruent to 1 modulo 7. So what number could x sub 4 be? Could it be 1?
No.
2. 60 minus 1 divisible by 7? No. Could it be 3? 90 minus 1 divisible by 7?
Yeah.
No. 4. 120 minus 119 divisible by 7.
Yes.
What did I just say?
119.
119
40,
is
49,
divisible
70.
by 7.
Yes, it is.
Yes, it is. So what number did we just say? 4 then, yeah? So you have to find some number, because there's an infinite number. Now, once you find all of these numbers, then it says, let x sub 0 equal m1 a1 x1 plus capital M2 a1 a2 x2 plus capital M3 a3 x3 plus capital M sub 4 a4 x4. Okay?
Wow.
So what is this number? We're gonna do some multiplying here. Go!
What's M1?
Tranner, do you have a little bit of Chinese in you?
Yeah.
Because Chinese
Yeah.
major theorem is just in the Chinese people.
Yeah, I'm actually Chinese.
Who?
That's questionable.
Okay.
I'm actually
Max, I
Chinese.
see 4 max.
Okay, so what's capital M1?
See max, max, max.
105.
105 times A1. Where's A1?
What's A?
What's A?
Look,
Oh,
look, this
it's one.
is
It's
A1,
one.
A2, A3, A4.
1.
1. And what was X1? 1. Plus
1.
M2,
70.
70. These are the capital M's right here, yeah? Okay, so 70, A2,
2.
2, X2, 1. Plus M3,
42.
42
3.
times A3, 3
3.
times X sub 3, 3. Finally, capital M4,
30.
30. Why am I putting parentheses?
4.
It's easy just put a dot.
4.
A4 is 4, and then X4 is 4. Okay, now we need to compute this number.
105.
I'll do the first one, 105
One-
The second one,
140.
plus 140 plus 42 times 9. Or should we go 40, or should we go 120?
Wait, why is it
378.
What? Yeah, 42 times 9. What's 42 times 10?
140?
What? Oh, that's not a 7. That's not a 7.
Oh.
Wait, what is this? This is a
70 times 2.
Oh, 70.
Yeah,
Yeah.
yeah.
I was like, that's.
Okay, we can do this in our head. What's 42 times 10?
378, Mr.
No, I'm just asking these guys.
Okay.
See, when you multiply by 9, why not just think of the 9 as 10 minus 1? So you go 420 minus 42.
Yes.
That's too difficult because you gotta borrow. Or so it just
I
used to go
multiply
42 times 9. 8 carry 1, 378.
Yeah.
Okay, whatever. And then what's 30 times 16? Well, 16 times 30,
4,800.
480.
Never mind, that's what
Okay, so what's the best way to add these numbers? If I were me,
What did-
I would add these two numbers together first and get 620.
Plus 105.
725.
And then I would add these two numbers and get 483. Correct?
Yes.
So, if you add those two numbers,
110.
3011. 1103. Yeah.
I think, wait, is there a better way? Because like, I remember doing this and it being like you just sub in a bunch of stuff and not having to like do inverses like this and test them out. So like,
What do you mean inverses?
because
That's
right
the way
now,
I remember doing
you're
it.
doing the inverse, you're finding the inverse of 105, right?
What do you mean the inverse of 105?
Like with respect to mod, like that's an inverse. You have to like guess and check.
Yeah?
But like you can just plug them
Oh,
in.
guess and check.
Like you can create an equation and just plug in a bunch of those equations all into one.
Well, I don't know, this is how I remember doing it. I'm sure there are other ways. Okay, so finally, and thus, finally, are you guys following on the notes? And
Yeah.
thus, x equals x naught, what is x naught? 1103
235.
plus capital M, what is capital M? Here's capital M, what is capital M, Tran?
Oh, I don't know.
No,
25 times
21
6.
times
210.
10, easy. 210k for some integer k. So, therefore, what is the smallest number that satisfies these four properties here?
1103.
Yeah, plug in 0.
No, not 1103, because what if k is -1 or -2?
Oh, what?
Yeah.
Oh.
The k is an integer.
Oh, plug
K
in
is an integer. So
Negative.
I'm thinking, okay, what if k
Negative
is 5?
-5?
No, -5. So what if k is -5? What does this become?
No can. 1100.
Okay, 210, how come I can't do things in my head like I used to?
What?
So it would be, if k is negative 5, you're going to get minus 1050, right?
Yes.
So what is 1103 minus 1050?
53.
350, so 53 is the smallest number that satisfies that property. And does that work? If you divide it by 2, you get 1 left over. Divide by 3, you get 2 left over.
Uh-huh.
Yeah. Yes.
Yes.
Wait, 2 left
51.
over.
Yes, yes.
51 plus 2.
What?
51.
Oh, yeah. Divide by 5, get 3 left over. Divide by 7, get 4 left over. I think it works. You can't get anything past the Chinese.
But those are very easy our way.
No, but when you get used to doing this,
It's fast.
then yeah, you just get, you're not gonna show every step, because, look,
Max,
come here.
max,
You already know the 2's gonna cancel out, right? You know what I mean?
Yeah.
You can do it really fast, but you gotta practice. You know, back in the old days, like 20 to 40 years ago, this used to be an event for math team.
Huh?
It's called congruences.
Modular?
Yeah, modular arithmetic.
That's crazy.
They used to have like an extracurricular event every year, and it would rotate, so sometimes it would be congruences, sometimes it would be group theory, sometimes it would be statistics, and one year was the binomial theorem.
That's a binomial theorem.
So could you repeat a problem like this on the test? Well, you're gonna have to.
No. Gotta memorize everything.
Yeah, so when we come back, I'm gonna assign you problems, but then we only have 2 days then, yeah?
Mm.
Okay, we're gonna do a practice test on Monday. Tuesday, take the test Wednesday. Well, it's not really a test, we just call it a quiz. The quiz is that a mosquito bite? The quiz is gonna be one problem like this: find the last 3 digits of
Root 2.
no,
Of the biggest prime
like
number.
34 to the 56th power. Or is that too much? Just last 2 digits good enough?
Yeah, I forgot to do it.
And then the Euclidean algorithm, find the greatest common divisor of, don't worry, I'll come up with some really good numbers, not like the numbers I picked there, something and something. And then what about this one? Except, instead of 2, 3, 5, 7, why don't we do 2, 5, 7, 13?
Oh.
Yeah! Or how about just 3 of these then,
Guess
instead of 4?
Yes.
Well, when we come back,
Yeah, I'm gonna be guessing
we'll do
check.
that.
Do I get credit for guessing check? Like, what if I just like?
But it's gonna say, use the Chinese remainder theorem.
What if it doesn't?
Okay, you know what, then, we're gonna make the numbers 101, 217, and then you can guess and check.
Yeah.
No, this is, whenever we had congruences as an event for Math League, the Chinese remainder theorem was always the C problem. In fact, we're gonna do it. I'll show you the whole problem. We can do it when we can come back on Monday then. Okay, we're done. Chime gotta leave in 10 minutes.
Yes.
Okay, so let's play a game for 10 minutes then.